Salutations, mini mathematicians. Greetings. We are going to be getting into Module 5. So there are 7 exponent property rules that we will be learning the shortcuts to in this module. So today, 5.1b exponent properties, our purpose is simplify exponential expression using 1, the product of powers, and 2, the quotient of power rule. So we're learning 2 rules in this lesson today. And we're going to be able to find values for x when applying these rules to equations such as 3 to the x plus 4 power times 27 is equal to 3 to the 10th. And that's going to look easy peasy by the end of this lesson. So let's get started. Okay, so 5.1b lesson. So we are going to further investigate expressions with exponents by combining them through multiplication and division. And there are special properties to help you transform exponential expressions with a rule, and they're called exponent properties. So we're going to look at patterns when we expand exponents and see if we can see a slick trick to make simplifying much more efficient. So I'd like you to take a look at 1 and 2. So 1 asks you what's 3 to the 4 times 3 to the 6 simplifies to 2, and choose all that apply and explain your reasoning. So if you want to use a calculator to think about what those are, you can, but also I want you to think about just not how you get to the number, but how are the numbers interacting with each other. Go ahead, pause the video, finish 1 and 2, and then we'll go over these in a second. Okay, well, which ones did you choose? Well, let's first look at 3 to the 4th times 3 to the 6th power. Well, 3 to the 4th power, we know, is 3 times 3 times 3 times 3. So there's 4 factors of 3. And 3 to the 6th is 3 times 3 times 3 times 3 times 3 times 3. And please write this down on your paper with me. So here, remember, exponents look up high. That's how many times you multiply. Well, here we're multiplying 3 how many total times? That's right. It's 3 to the 10th. It's 3 multiplied by itself 10 times. Well, how can we get 3 to the 10th from 3 to the 4th times 3 to the 6th? That's right. We're adding the exponents because we're multiplying with the same base. On your calculator, this is called the caret button. It helps you do any exponent. So if you do 3 your base, raised to the power of 10, and then press equals, we will get that 3 to the 10th is equal to 59,049. I would not expect you to do that on your own. If you have a phone, what you can do is when you go to the calculator, you can turn it and it turns into a scientific calculator, and you have x to the y power. So I always say when you're dealing with a new calculator, check a number you already know. So like we know 3 squared is 9. So you can do 3, and let's see if we press that button and then square and then enter, and it's 9. So we can try this one. So 3, and then press the x to the y button, saying 3 is our base, and we're doing it to the 10th power. So we press 10 and equals, and we get the same number. So scientific calculator on your phone is a great resource. Using a scientific calculator that you have not on your phone, an excellent resource. Okay, so let's take a look here. Well, I know that 9 to the 5th power. Well, what's 9? You guys, 9 is 3 squared. 9 is 3 squared. So this is 3 squared to the 5th power. Well, think about this. Look up high your exponents, how many times you multiply. Well, what's your base here now? It's 3 squared. This is 3 squared times 3 squared times 3 squared. 1, 2, 3, 4, 5 times. Well, think about this. That's 3 times 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 3. How many factors of 3 are there? There's 10. This is 3 to the 10th power. So we know B is definitely equivalent. Awesome. Okay, what other ones did we pick? Well, we of course picked D because that is equal to the decimal expansion, 59,049. And 3 to the 10th, we saw that that's also equal. So we can always like draw an arrow up here for that reasoning. Well, let's think about some of these other ones. Well, 9 to the 24th, well, can we do this same thing? Where 9 is 3 squared to the 24th. Okay, I'm not writing this out 24 times. So if you have 24 groups of 3 squared, 24 times, how many total factors of 3 would you have? That's right, 48. So 3 to the 48th power, so that's not it. And 6 to the 10th, well, 6 to the 10th, I can't rewrite 6 as a power of 3. So if we just look at 6 raised to the 10th power, wow, that is a big number. Let's see. 604666176, then count back for your commas. 60,466,176. Wouldn't mind for that to be my bank account right now, right? Okay, so obviously that is also not equivalent. And 6 to the 24th, well, 6 to the 10th isn't equal, you guys. 6 to the 24th is even bigger. So obviously we are not going to pick those. So you should have picked B as in base, D as in denominator, and E as in exponent. So how do you multiply exponents with the same base without expanding? So without expanding is kind of like what we did up here. We expanded it out to all the multiplying. And use an example just for your explanation. So when bases are equal, add the exponents. Keep the base the same. Keep the base the same. So my example is going to be 5 to the 8th times, that's right, we have to have a base of 5 because we have a base of 5 here. So 5 to the, I don't know, let's use 2, is equal to, this is 5 to the 8 plus 2, which is 5 to the 10th. Just a coincidence, we end up to the 10th power again. It's not what has to happen. So the algebraic rule for the, are you ready for the name? It's called the algebraic rule for the product of powers. So that means product we're multiplying, so we're multiplying powers. Powers is another word to say a base with an exponent. So the product of powers rule states that x to the a times x to the b is equal to the x to the a plus b power. Excelente. Fabulous. And so sometimes I like to say, when multiplying with the same base, add your exponents. See how the multiplication cross, when it goes up into the air, turns into the plus? Okay. Cool, Mrs. Barr. Okay. Simplify each expression. You guys do have to show some work, and some of that work could just be circling the 5 and the 3 exponents and putting a plus sign. So x to the 5th power times x to the 3rd power is x to the 8th power. Remember, when x variables are next to each other, they're being multiplied. If you wanted to show some more work, we could circle and add and say, well, this is x to the 40th power times x to the 3rd power. So we're going to have a total of 43 factors of x, or x to the 43rd power. Fun. Okay, so the next one, remember you have to have the same base. So I have a lot of students who'll be like, oh, a to the 3rd, b to the 2nd, that's ab to the 5th. It doesn't work that way. Remember, this would be a times a times a times B, oh, 6 A's, 1, 2, 3, 4, 5, 6 factors of A's, and then 3 factors of B's. So what's important here is we're going to rewrite this as A to the 3rd times A to the 6th times B to the 2nd times B to the 3rd. And you might think it's silly now that I'm showing this work, but these problems are going to get much more complex, and we're going to add more rules. So it's really helpful to move around your factors using the multiplication commutative property. Commutative property multiplication, you can move around as long as everything's being multiplied. We can change the order to make this more efficient. So again, That's going to be a to the 3 plus 6 factors. So we have a to the 9th, and b to the 2 plus 3 factors, and b to the 5th. Notice my final answer has no multiplication dots, no parentheses. There's no more math to be done. Okay. So you are going to continue on. Go ahead, finish 7 through 12. Pause the video, finish 7 through 12, and we're going to go over them as soon as you're ready. Okay, let's see how we did. Number 7, x to the n times x to the n times x to the n. Since all the bases are the same, we have x to the n, which is x to the 3n. Remember, n plus n plus n is 3n. Number 8, we have we have a b to the 5th and 8a squared b. Again, move around your factors. Everything's being multiplied here, so I'm going to bring my 8 in front, bring my a's next to each other, and my b's. If there's no exponent there, it's to the power of 1. So here we have 8, a to the 3rd, b to the 6th. It's really important that our final answer, our coefficient is in front, our number is in front, and then our variables are in A, B, C order. So that's really important. We can even write it on our note somewhere that we need to make sure coefficient is in front, variables in alphabetical or A, B, C order. So this is super important. Maybe there's 2 F's in coefficient. I'm not sure. Coefficient is in front and variables in alphabetical order, A, B, C order. That's how you know your answer is in simplest form, and that's how we are communicating that we have the same answer. So the next one, you'll see, again, since everything's being multiplied, we brought the 2 and the 4 next to each other. We brought all the x's next to each other, all the y's and all the z's. I find writing that exponent of 1 to be really helpful for me so you don't lose any of your exponents. And then 8, x to the 3rd, y to the 4th, z. No parentheses, no multiplication dots, and it has to be written that way. We are not writing it in any other order. Awesome. Okay, number 10. 10, notice we're still multiplying with the same base. Our base is y. So what do we do when we multiply with the same base? Add our exponents. So when we're adding our exponents here, we have n plus 1 plus n minus 1. N plus n is 2n, and 1 plus negative 1 is 0. So it's just y to the 2n power. Okay, number 11. Here, again, move all of your coefficients numbers to the front. So this is a -1 and a -1. So -1 times -1. I brought my a's together, so a to the 1st and a to the 2nd, and then my b's, b to the 1st and b to the 5th. From here, -1 times -1 is +1. A to the 1st times a to the 2nd is a to the 3rd, and we get b to the 6th. Again, my final answer, a to the 3rd, b to the 6th. No multiplication dot, no parentheses in alphabetical order. The next problem is a great problem. Taking a look at it, we have multiplication here, but then we have addition. So we have to be really careful here because here we're multiplying with the same base. So we can move around the factors in this term. So here I can say 2 times 3, x to the 3rd times x. So I get 6x to the 4th. I'm adding that to 5x to the 4th. Well, what if you have 6x to the 4th and another 5x to the 4th? X to the 4th powers is, you'd have a total of 11x to the 4th. Because these are like terms, they have the same variable and exponent. If you had something like x to the 3rd and 3x to the 3rd plus 5x to the 4th, you could still use your product of powers here because x to the 3rd and x to the 1st. So you'd have 3a to the x to the 4th. Plus 5x to the 4th. And from here, you can't really add 3a and 5. You wouldn't be able to add them here because you have this extra variable. This ax is not the same as x to the 4th. Ax to the 4th is not the same as x to the 4th. I can't say this is 8 ax to the fourth. I'm just kind of stuck here. This is as far as you could go for this problem. So just be aware of, do you have like terms or do you not? If you have like terms, go ahead and add them. Okay, so 13 asks you which value is greater, x times x to the fourth or x to the fifth? Explain. Which one do we think is greater? Which one's more? Remember, this is x to the first. So which one do you think is greater? You're right. Trick question. Trick question. They are equal. X times x to the fourth is equal to the x to the first times x to the fourth, was equal to x to the 1 plus 4 using the product of powers, which is x to the fifth power. Excellent job. Okay, so let's take a look. So we're going to look at our second rule. So let's see what we can think and find when observing these values, looking at these patterns. So I want you to pause the video and look at 14 and 15 and explore. And I want to know, what does 3 to the 6 over 3 to the second simplify to? And circle all that apply. Go ahead and pause the video now and select your answers. Let's see how we did. So let's expand 3 to 6 over 3 to the second and see what this is. So remember, 3 to the 6 over 3 to the second is 3 times 3 times 3 times 3 times 3 times 3. Did I get 6? 1, 2, 3, 4, 5, 6. Over 3 times 3. If you should be able to see that. If you are only multiplying in your numerator and in your denominator, you can cancel out common factors. Cancel out common factors. Just like if you had 12 over 16, right? 12 is 4 times 3, and 16 is 4 times 4. So those 4s cancel out, so you get 3/4. Or you can always think, oh, I'm just dividing by 4. And that's why we can do that, because they have common factors. And 4 over 4 is 1. So here, how many 1s can we make? Well, we have 2 factors of 3 that cancel out and make 1s. So if we have 2 factors cancel out, how many are left over? 4 of them. Where are they? In the numerator. It's wherever you have more. So this is equal to 3 to the fourth over 1, which is 3 to the fourth. Okay, well, we know it's B then. We can look at this. Okay, well, if it's 3 to the fourth, it can't be 3 to the third, because you can't multiply 3 times 3 times 3 and have it equal to another factor of 3 being multiplied. That's ridiculous. 1 to the fourth is equal to 1. 1 times 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 1, whatever, however many ones, it's still going to be 1. And then, well, does this equal 81? Well, here is my to the fourth power trick. So 3 to the fourth, you're going to take 3 to the second times 3 to the second, and it gets 3 to the fourth. So 3 to the second is 9, 3 to the second is 9, so 3 to the fourth, 9 times 9 is 81. So we can think 3 to the fourth is 3 to the second times 3 to the second, 9 times 9, which is 81. So we're going to also select D. So that's kind of explaining our reasoning here. Okay, so we're going to explain how to divide exponents with the same base without expanding. So we're not expanding like this. We're going to use an example. So to divide, or to find the quotient, math vocabulary fun, to divide powers with the same base, subtract the exponents, and keep the same base. Write your power where the larger exponent was. Think about, where's the leftovers? Where are the leftovers after you cancel out? So let's give 2 examples. So my first example I'm going to use is 2 to the 8th over 2 to the 3rd. So there's going to be 8 factors of 2 in the numerator and 3 factors of 2 in the denominator. How many factors of 2 will cancel out? 3 factors of 2 will cancel out. How many will be left over? 5. Where will they be? In the numerator. In the numerator, because that's where the leftovers were after we canceled out. My second example, I'm going to just switch those around. So maybe I have 2 to the 5th over 2 to the 17th. Okay, how many factors are in the numerator? 5. How many factors in the denominator? 17. How many factors will cancel out? 5 of them. How many will be left over? 12. Where will they be? In the denominator. So this is 1 over 2 to the 12th, which is a great answer. Okay, so the algebraic rule for the, are you ready? Are you ready? I know when I tapped my desk, it kind of made like it made my camera look weird. So over here, I'll try it. Algebraic rule for the quotient of powers. Quotient, we're just dividing, of powers. There's a base and an exponent. States that if A is greater than B, okay, it's super mathy, I know. But that just tells you what? The exponent is bigger in the numerator than the denominator. That means that it's equal to x to the a minus b. The leftovers are in the numerator. But if a is less than b, or you can always think about b is greater than a. I usually like to think about what's bigger, right here. Where are your leftovers? So if b is greater than a, or a is less than b, tomato, tomato, x to the a over x to the b turns into 1 over x to the b minus a. Because we want to think about where are the leftovers. After they all cancel out, they're going to be in the denominator. Wonderful. What's really important here is can never leave negative exponents in your answer. It is not simplified. We can never leave negative exponents in your answer. So if you were up here and you're like, oh, I just subtract 5 minus 17 is negative 12. You can't have negative exponents. We'll deal with them in a couple days, but right now, no negative exponents in your answer. And for the whole module, if you leave a negative exponent in your answer, it is not simplified all the way and is considered wrong. Cool. Okay, so taking a looky-loo at this practice now that we have 2 rules, we're going to be able to combine them and use them. I'm going to do 17, 18, and 21 with you. And again, if we run out of space, we can always move to a separate piece of paper because it's just always nice to have enough room so we don't have to write tiny and make a silly mistake from there. Okay, so taking a look at 17, oftentimes when I have a lot going on in my numerator and denominator, I like to break it into organizing them with a fraction just with my numbers, and then breaking it up with a fraction with my equal bases. So here I can continue simplifying after I've organized my terms, my factors in my problem. And again, you might be like, Mrs. Barr, this one I can do in my head, but they're going to get more complex. So let's learn how to approach the problem and break it down into smaller parts before it gets really crazy. And then you're like, I can't do this. Be like, oh, let's look at one that was simpler and how we can find tools to help us. 6 over 2, we know is 3 over 1. X to the 4th over x to the 2nd. There's 4 factors in the numerator. There's 2 factors in the denominator. 2 factors will cancel out, and the leftovers will be in the numerator. There'll be 2 left. So our final answer is 3x to the 2nd, all in the numerator, so we can just give that as our answer. Remember, final answer, no negative exponents, no parentheses, no multiplication dots. Coefficient in front, variables in alphabetical order. Cool. Okay. Moving on to 18. Again, what do we want to look at? We want to breaking this into organizing into fractions of same bases. So I have a to the 7th over a to the 1. I got b to the 10th over b to the 3rd. And I got 1 over c to the 2nd. Don't say it's 0 over c to the 2nd, because then your whole numerator is 0. Multiplying everything by 0 just zeroes it all out. Careful. Okay, so a to the 7th over a to the 1st. There's 7 factors in the numerator, 1 factor in the denominator. 1 factor cancels out, and you're left with 6 in the numerator. Okay, next one. There's 10 factors of b in the numerator and 3 factors of b in the denominator. 3 factors will cancel out. You'll be left with 7, and they'll be in the numerator. And then we just have 1 over c to the 2nd. So then multiply this across and simplify. I end up with a to the 6th, b to the 7th, all over c to the 2nd. Final answer. Okay, let's take a look at the next one. I'm going to do 21 with you. Okay, first of all, notice we still have the same base. We still have the same base of f, but our exponents are n plus 3 and n plus 1. So we have to ask ourselves, which one's bigger? So if I have n plus 3 comparing to n plus 1, what's bigger? N plus 3 is bigger. So that means that this is going to turn into f to the n plus 3 minus n plus 1 power. Okay, so now from here, we're going to have f to the n minus n is 0. 3 minus 1 is 2. But where was the larger exponent? In the top. So we know our final answer is on the top in the numerator. So it's just f to the 2nd power. Just f to the 2nd power. Perfect. Okay, so what you're going to do is you are going to finish 20, 19, 22, and 23. So go ahead and work on those problems, these 4 problems. Pause the video and we'll go over them in just a second. Okay, let's see how you did. So when we are looking at 19, we broke this into the fractions. So 2 over 8, m to the 5th over m to the 3rd, n to the 3rd over n to the 2nd. So from here, we have 2/8 is 1/4, so we just have 4 in the denominator. M becomes before n, so m to the 2nd n. M squared n all over 4. Perfect. Okay, so taking a look at number 20, we have d to the 2n over d to the n. So remember, what is the larger exponent? 2n is definitely bigger than n, so our power is going to end up in the top in the numerator, and 2n minus n is 1n, just n, so d to the n power. And 22, Okay, so we have 2 over 6, and we have g to the 2n minus 1 over g to the 2n minus 5. So taking a look at this problem, we have to think about what's bigger, 2n minus 1 or 2n minus 5. Well, if you subtract 5 from something and you subtract 1 from that same something, the one you subtract 5 from is smaller. The one you subtract 1 from is bigger. So taking a look here, we have g to the 2n minus 1 minus all of 2n minus 5. So the bigger one minus the smaller one. The bigger exponent minus the smaller exponent. So here, 2n minus 2n is nothing. It's gone. -1 minus -5. So thinking about this, -1 minus -5. -1 plus 5, which is 4. Okay, so just in case you needed to show that work off to the side, totally fine. So we have g to the 4th in numerator and just 3 in the denominator. Nice work. Okay, well, when we take a look at Oliver, so we had Oliver states that x has to be 4 because 4 times 2 is 8. And Thea said, no, no, no. 2 to the 4 times 2 to the 2nd expands to 6 factors of 2. You like what I did there? So I didn't have to say 2 so many times. Which equals 2 to the 6th power, not 2 to the 8th. So do we agree with Thea or Oliver? Explain your reasoning. We agree with Thea. Thea? You add exponents when multiplying with the same base, not multiply. Remember, when you're adding with the same base, you multiplying with the same base, you add your exponents. Okay, so that is the rule. It's called product of powers. So this would be 2 to the x times 2 to the second is 2 to the eighth. So the rule is when we look at these exponents, x plus 2 is equal to 8, so x has to be equal to 6. So we are going to use these exponent properties and solve for x. So what we're doing is we're using exponent properties to write a new equation. And then solve for x. And we have to show all our work. So I'm going to do 24 and 26 with us. So 24 is 3 to the x times 3 to the x is equal to 3 to the 16th. Well, again, remember multiplying with the same base. We have all the same base here. What do we do with our exponents? We add them. So our new equation is x plus x is equal to 16. You can say 2x is equal to 16. Divide both sides by 2, and x has to be, you're right, 8. Okay, but remember, this only works if we have the same base. We have to have the same base. Oh no, 26, you guys, we don't have the same base. Woe is us. We have a 36 and a 6. Oh no, what will we do? Oh, it's not that big of a deal. So don't be so dramatic. What we can do is we can rewrite them all with the same base. Well, do you want to rewrite 6 with a base of 36 to a power? You can't do it. Or 36, rewrite it with a base of 6. That we can do. We know that 36 is 6 to the second power. We okay with that? Perfect. Times 6 to the x is equal to 6 to the 3x plus 1. Yay! Now we have the same base and we can use our power of products. Product of powers. So taking a look here, we're going to use our exponents to write our new equation. 2 plus x, when we add our exponents, because we're multiplying the same base, it's going to equal our exponent of our product. So here, okay, this equation, a little trickier, but nothing you can't handle. Subtract x from both sides. 2 is equal to 2x plus 1. Subtract 1 from both sides. 1 is equal to 2x. Man, this is like 7th grade stuff. This is kind of fun, right? We're combining all our skills. So x is 1/2. Groovy. So remember, we are making sure all our powers are written with the same base, and then we're writing a new equation using the exponents to find x. Finish 25 and 27. Pause the video, finish 25 and 27, and we'll go over them in just a second. Okay, let's take a look. 25, they all have a base of 2. Remember, this is an exponent of 1. So we have an equation here with just our exponents that says 1 plus x minus 1 is equal to 7. Well, 1 minus 1 is 0, so this equation is just x equals 7. Groovy. Okay, let's take a look next one. Woe is us. We do not have the same base. What will we do? We can't use our rules to rule the world. That's okay, just rewrite it. Okay, which one do you want to rewrite? 5, 25, or 5? Let's rewrite 25. 25 is, yep, it's 5 squared. That 5 kind of gave it away. 5 squared, and we're just going to bring down everything else. And then remember, we are rewriting a new equation using these exponents to get our new equation of x plus 2 is equal to 7. X plus 2 is x plus 4 is equal to 7. Subtract 4 from both sides, and x is equal to 3. Wunderbar. Excellent job, mini mathematicians. Great work with the first 2 out of our 7 rules of the module, and I will see you next time. Do your best and be nice to everyone.